Okay, I'm going to make this video in case I run out of time tonight, and it's incredibly important because it seems to botch you up every single time. So when we're dealing with a fraction, I want you to realize one very simple thing. This fraction just means 6 divided by 7. Now, if we're leaving it in a fraction form, we just leave it like that. If we want it in a decimal form, we actually take our calculators and we take 6 and we divide it by 7, and this is called the decimal form. You can see why sometimes we don't want to write the decimal form, because not only is it inaccurate, it takes forever to write it accurately. And if we write it just like that, it's not the same fraction anymore. If I convert that back, it's not going to come out as 6 over 7. So this is just called a simplified fraction, in that this number and this number cannot be divided by anything anymore, and it's far more accurate than the decimal. So most of the time in this grade, you're going to be dealing with that. But I want you to notice something. If I multiply this by 7, for whatever reason, I do not have to multiply this first and then divide by 7 first. I can just say, okay, well, this is 7 times 6 divided by 7. I'm allowed to rearrange that any way I want because they're all multiplying and they're all dividing. Well, 7 divided by 7 is clearly 1. So I quickly learn with fractions that if I multiply by the denominator, it disappears. This is essentially called multiplying by the reciprocal, which I use a lot, but it just means I'm going to multiply by that to get rid of it. I also want you to notice that if I were to multiply by 1 over 6, for whatever reason, I do not have to multiply out here and multiply out here and then simplify. I can just say, well, they're all multiplying, so therefore I can move my 6 over here first and say 6 divided by 6 is 1. And we quickly learn that if we multiply by whatever's on the denominator, if we multiply it by its numerical, so something on the top, the numerator, a reciprocal, and that was not a reciprocal, that they will cancel out every time. This is a handy way to get rid of a number or a situation. So if I'm dealing with this situation and I want to solve it like that, I can multiply, and I don't like my fractions or dealing with a fraction. I can multiply, and as you get more advanced, you'll learn to multiply and get rid of everything. But I can multiply by 7 on both sides. And that's the key to math. Just remember that big main rule. Whatever I do to the right, I can do to the left. The only exception is when you're multiplying a fraction by 1 over here, you're actually not changing it. That's the only exception. But if I'm just going to multiply by a random number, I must multiply both sides. Well, the same rule applies. This cancels. Oh, and I had to have an x there, 6x. So I'm going to go back and just write it properly. Oh, no, I've got it there. 6 over 7, x is equal to 6. The only way this is possible is if x is something. So to figure this out, my first rule is I don't like fractions. Always just look at all your fractions and say, what are the denominators? Well, this is 6 over 1. So the only fraction I need to worry about is 7. So that means I'm going to multiply both sides by what's essentially 7 over 1. But I don't write that. I just write multiply by 7. And I must do it on both sides. Well, the rule is these disappear. That's why I did it. Okay, so I'm left with 6x, and on the right side, what is 6 times 7? So another habit that you don't want to get into is never leave numbers unresolved. You can resolve them. 6 times 7 is 42. And now what must I do? I must divide by 6 on both sides to get rid of that 6. And that's just algebra, which you know already. So we need to algebraically get rid of those fractions, and that's what I want you to focus on. Well, it's clear that those cancel, and 42 divided by 6 is 7. So that means for this to be true, for this equation to be true, x must actually be 7. Which makes sense when I look at it like this, because the 7s will cancel, and indeed 6 is equal to 6. And that's proving left side, right side. But people get snagged up with these fractions. They start doing weird things like dividing by 7 on each side. So we need to practice. And our first step is we're going to say, what's the number at the bottom? that's bothering us. When there's just one of them, it's easy. When there's two, it's harder. So we're going to do situations where there's two and where there's one. We'll probably do this one next, actually. Well, it's clear the 6 is bothering me. So remember, we're just going to multiply everything on each side by 6. And remember that when I do this on this side, it automatically gets rid of it. Just like that. Okay? So that's why we're doing it. What happens on this right side? That becomes 24. So when these things cancel like that, that's why I'm doing it. So I just want you to remember, I'm looking for the denominator, and I'm just looking to cancel it. If I multiply a number that is at the denominator, it will disappear. And look, I'm left with this. What do I do next? I divide both sides by 3, just like algebra. And it's clear that x is equal to 8, right? Must be 8. And then when I go back and I check this answer, it's quite clear if instead of x, I put an 8 in there. So I'm just going to put an 8 where x is. It all makes sense because left side, 3 times 8, 24. 24 divided by 6 is 4. Left side matches right side. Therefore, x must be 8. That's why we're doing it algebraically. We don't want to just sit there and guess x over and over again. But sometimes we're going to have fractions on both sides. Not a lot yet, but it's going to happen. And in this situation, and actually let's deal with a slightly easier one. This one here is slightly easier. I have two fractions, which is a bummer, but I can see that it's 6 on this side and 6 on this side. So up here, I would just put everything in a bracket, just to not get confused by what you're writing. On this, you don't really need it because there's just one. I'm going to multiply both sides by 6. Now keep this rule in mind. When I'm multiplying, this is the denominator, that's the numerator, they're going to cancel. And over here, thankfully, they cancel. So I'm left with x plus 4 is equal to x. What the heck? How do I solve that? X plus 4 is equal to x. Well, at this stage, you must get all your x's on one side. You must get all your x's on one side. So I subtract an x from this side. And actually, this one doesn't work because I forgot to include a number on the other side. But that's how you get rid of the 6, and that's the point. So in this case, it had to be something like 2x. So when I subtract 2x from this side, I'd get minus x plus 4 is equal to 0. And then I have to move the 4 to the other side, and I get minus x is equal to 4, or minus 4. And this is essentially a minus 1 multiplying my x, so I have to divide both sides by minus 1. And it's clear x is equal to 4. The only thing is up here I had to have 2x instead of 1x over 6. Same with this one over here. I'd have to get, no, actually this one will work out fine. So now let's look at a slightly more complicated situation. What happens when I have two numbers that don't match? Well, this quick method is you can just multiply them and say 30. I'm going to multiply both sides by 30. What happens when I multiply this side by 30 and this side by 30? Well, keep in mind everything is multiplying and dividing. So this 30 will just divide by this 6, and this 30 will just divide by this 5. It's clear that it's 6 on this side, and it's clear that it's 5 on this side, 30 divided by 6. So let's go back and see, and just do it this way. What's 30 divided by 6? Remember, a fraction is just a division. 5. And what's 30 divided by 5 over here? It's 6. And suddenly we realize that, okay, we have 5x is equal to 6x. That makes no sense. How do I solve this? I get x on the I want to get my x's on both sides. That's the rule. And it turns out this one has a silly answer. I get minus 1x is equal to 0. Divide both sides by minus 1. X must be 0. That's the only way this one works out. However, it's the fractions I want to focus on. I had to do that to the fractions to get rid of them. Okay? Sometimes you'll have even weirder situations like this. And you same thing. I'm going to multiply both sides by, what's the number when they multiply together? 30. Sometimes I'll find a smaller number, but in this case, it's 30. And immediately I say, what's 6 divided by 30? It's 5. It's 5. So I get rid of that side of it. And on the right side, what's 30 divided by 5. It's 6. It's 6, and I immediately get rid of that. So it's 6x on the right and 5x, 5 times the bracket on the left. In this case, I now have to distribute properly and go slowly, and I get 5x plus 20 is equal to 6x. And in this case, I've got to get all my x's to the same side, so I'm going to subtract 6x from both sides. And over here becomes 0. And then my next step, and 5 minus 6x here becomes minus x. And my next step will be to get rid of that 20 on the left side. So I'm going to subtract 20 on both sides. Always the secret, subtracting on both sides. And it's clear that I'm left with minus x, and these will cancel out. Minus x is equal to minus 20. When I divide by minus 1, it's clear x must be 20. If I go back to my original equation and take 20, it will work out. So that means that the only way this will work is if x is 20 on both sides. Let's see if that's true. If I put 20 here, 20 plus 4 is 24. And over here, if I put 20, 20 divided by 5 is what? A fraction is just a division until you can no longer division. But if you can divide it equally instead of a decimal, do it. So over here, it becomes 24, right? That becomes 20 plus 24 is 24, and 24 divided by 6 is 4. Left side equals right side. Yeah, nice try. There we go. Left side equals right side, therefore 20 was indeed the answer. Let's move on to something that's more related. We have lines. We have quite a few lines, and let me just look at them. So in this case, visually, I can tell exactly where my B is. But I need to find out the line formula, and I'm just going to pretend they gave me, I didn't have to figure out M. I have my M, and I have 1 point. Well, my first step is going to be write the line formula. I need to find out this line. Y, the line formula is always Y, is equal to mx plus b. And the only information I have so far, I don't have b. Even though on the graph I can see it, I'm going to pretend I don't. I have m, though. I'm going to replace my m here with this 5 over 3. Like that. What's the problem I have? Just like I had before. What's the problem I had? Just like the problem I had before. I have a fraction here. Oh, and first of all, I want to solve it. I can either get rid of my fraction problem right now, or I can wait. But let's pretend I just want to solve my fraction problem right now. No, you know what? You're used to going in this method. So now all I need is a point to solve this. And well, fortunately, they gave me a point. So I'm going to rewrite this. And actually, I want to rewrite it clean because I notice I have a bad habit of writing everything unclean. So I'm going to rewrite this. I get y is equal to mx plus b. Always write your formulas. That way we won't make as many mistakes. And then my next step is I'm going to put the m in there. Like this. And then I'm just going to put its times x plus b still. And then they've given me a point. They've given me the point 3 comma 3. So where I see y, I'm going to put in 3. I'm going to keep the 5 over 3 here. Like this. But now for x, when I see x, I'm going to put in a 3. Now in this case, it's canceled out beautifully, so I don't have to worry about 5 times 3 is equal like that. Boom, they cancel out. I get 3 is equal to 5 plus b. So this won't be too much of a problem as we go here. So that one worked out well. Let's see if the next one will too. Yeah, I'm worried that they all will. Yeah, they all will. So let's stop here and just pretend that your teacher said, okay, yeah, let's do this instead. So the b value here is minus 2. Let's say we figure out it's minus 2 because this is kind of defeating the purpose. But let's say you wanted to get rid of this fraction and you wanted to have it in a normal line situation, or you wanted to solve your b and you had an unusual situation. These lines all are terrible because I just realized it won't help us solve the fraction. But let's say I wanted to get rid of that 3 right now, the way it is. I want to get rid of the 3. I do the same thing. I'm going to multiply the left side of my equation by 3. And here's the trick. I can either multiply each of these 3 things by 3, which is really what I'm going to end up doing. But really, you should just take the whole thing like that. And we're always multiplying by that number. We're never dividing. We're never dividing anything unless we're solving something algebraically. We're getting rid of the fraction. When on this side, it's clear 3 times y is just 3y. On the right side, this 3 has to go through this bracket. It has to multiply each thing in the bracket one by one. So not only does it have to multiply the 5 over 3 by 3, 5 over 3x by 3, but it also, and here's the thing that a lot of students forget, this 3 also has to multiply this minus 2. So essentially, I've multiplied everything in there by the 3 to get rid of the denominator. And right here was the whole point. By multiplying by 3, I'm always just going to get rid of that denominator. The thing that people forget, though, is they've got to multiply this one by 3, too. So I get minus 6 here. So this has essentially converted it to the standard formula. So maybe I should just do that. I should say we're going to convert everything to the standard formula. And this will help you also solve it. Solve other tough line problems. So if I was to put that all on the same side, I'd have to get the y's and the x's on the same side. And I get this. And actually, it's not quite the real proper line formula, but that's how you do it. Now, let's say we have this one, too. And let's say we're given the fact that y is equal to that slope, x, and we're also given the b value of that. Okay, let's say we're given this as the formula. And your teacher said, I want you to get rid of all the fractions and make it the standard formula instead of the slope-intercept formula. So clearly you just look, this minus does not belong to that 2, by the way. We never put a minus in the denominator. It's always up. It helps us get rid of numbers. Clearly there's a 2. So I'm going to multiply everything by 2. This by 2, the 4 by 2, everything by 2. And what happens here, it becomes 2y. What happens here? That 2's cancel out. I'm left with minus 3x. So far, I've got 2y is equal to minus 3x. And then what happens when that 2 multiplies the 4? It becomes 8. Suddenly, they're all on the same line. I can put this over here. Now, you might say, well, yeah, but we're not doing standard line formulas. No, but we have a lot of situations where we have a fraction. And here's a good example. So I need you to master this question because it's on your test. And here's the question. And this is a few times that we've gotten it wrong. So that's why I encourage you, draw, draw, draw. Now, on a test, you might not have time, but you did correctly put your lines in the right spot. So let's at least do that. But before you start drawing midlines like you did, draw your triangle. Draw your triangle. Complete your triangle. Say, okay, there's my triangle. There we go. Looks like that. And they want me to find this midsection. Okay. So first of all, when you do the midpoint, you have to write down the midpoint formula because it's going to help you. Okay. So we have to take x1 and plus x2 and divide it by 2. And this is the midpoint we're looking for on the other side. Well, the x1's 8. The x2 is 4. So 8 plus 4 is 12. 12 divided by 2 is 6. So we know that the x value of this midpoint so far is 6. The y values, we add them together. So we've got to add 8 plus minus 2. Plus minus 2 is 8 minus 2, which is 6. And we have to divide that by 2, and here's where you make your mistake. 6 divided by 2, yeah, you got it, but that's not, it becomes 3 here. So boom, we have our midpoint. So let's go back and look at our questions. Here's another thing I want you to start doing. Go back and make sure you answer the question. Did I draw it? Yes, yes, I drew it. Did I draw a medium? Yes. Then did I find the equation of the slope? No, I've only found this midpoint. So if I want an equation in slope y-intercept form, that means she wants me to find this. Well, I'm missing a couple things. I don't know b. But I know the formula for slope. It's equal to y2 minus y1, and I have to use the y2 of the midpoint that I just find, over x2 minus x1, like that, as a fraction. Well, it would help if I labeled all my x1s and my y1s. So we're going to use the point A, and we're going to use the point midpoint. And I'm going to call over here, I'm going to label all my points. Okay, well, x1 is equal to minus 2. x2 is equal to 6. y1 is equal to 0. y2 is equal to 3. And you're very good at not mixing those up. But whatever x1 I just define, if I define it this, then this must be the y1. So that means now that I've labeled them, I can just replace them in here. So it's always good to rewrite it, though. So what was my y2? I just have to look on my left. I have to subtract, open brackets, my y1, which is 0. So it's 3 comma minus 0. Then at the bottom, I've got x2. I can just fill it in. And what was my x1? So minus 2. I have a minus 2 situation, which is a plus 2, which I think you got right. So now I have 3 over 8 as my slope. So I've successfully answered this question. Did I answer it all? No. Now I can just keep going and keep everything orderly, but at least now I know this. I'm going to keep these numbers around in case I need some of them later. Okay, now I have to go back and say I've got my slope. I need to figure out B, and here's your problem. So what point should I use? Well, I'll use the easiest one. I like positive numbers, so I'm going to use this point. So I'm going to fill in my y and my x, and I'm going to fill in my m from my slope, but I'm going to solve B. Okay, well, y over here is a 3. I could have used this point as well because it's on the same line. You're allowed to use any point that's on the same line. So I'm going to use the easy point, though. So the y is 3. My slope, I'm just going to bring it in from over here. Makes my life easier. And now my x that I'm going to use is, I might as well put it in brackets. I look up, I see it's 6. So 6 is that point. And then this is what I'm trying to solve B. So now what's our big problem, right? The whole thing I was talking about before. My big problem is I have this annoying division, and yeah, I could figure it out. In this case, it's 18 here. But 18 does not get rid of my 8. And yeah, I could actually simplify it a little bit, right? I could say they're both divided by 2, so it's going to be 9 over 4. So that's one way to go about it. Or I could just say, I want to get rid of that 8, and I'm going to multiply everything by 8. So that means I'm going to give them all a little bit of space. And I'm going to put this over here. It's going to multiply by 8. I'm going to leave a little space here. I'm going to multiply this thing by 8. And I'm going to multiply my b by 8. Okay, so it's going to be 3 times 8 over here. The nice thing about when I get to the fraction is when I multiply this fraction by 8, I don't even have to worry about it. It's going to cancel out with the denominator instantly. That's why I did it. And then I've got to remember, multiply my b by 8. And that's the thing that's hanging you up. So you're just multiplying everything by 8, and the nice news is this part always cancels. So we don't have to worry about that mess. It always cancels. We just have to solve this. It's 24. We can't solve the b, but we can solve 3 times 8. It's 18. Now, we have to solve b. So our first step is we have to subtract 18 from both sides to get rid of the 18. Just like all the algebra we practiced. We just need more practice doing this. When I subtract 18 from 24, it becomes 6. So I always want to make sure you check your numbers because that's one of the problems. 18 minus 18 is obviously that. That's why we did it. And I'm left with this. We're almost done. We're almost done. I need to get that b all alone, so I'm going to divide both sides by 8. You might say, oh, but I just multiplied by 8. Yeah, you're right. We multiplied by 8 earlier to make this simpler. It was in the cards that we were going to bring back that 8. It was always going to come back at the end. But the nice news is when I divide the right side by 8, it just disappears. And it's clear b is equal to 6 over 8. But never stop there. Say, wait a minute, can these be divided by any number that's in common? Yeah, they can both be divided by 2. So it's 3 over 4. We finally have what b is equal to is 3 over 4. What's our last step? Put it all together. So I'm going to bring this formula down. I'm going to give myself a lot of space. And where I see m, I'm going to replace it with my m that I figured out before. I don't need that bracket around the 3, by the way. That was just to make things easier. And what about my b? I'm going to replace it like this. Boom. And by the way, if your teacher said, I now want this slope-intercept formula in standard formula, which means no fractions, what do you think I would multiply both these sides by? You might be tempted to say 8 times 4, 32. But no, 4 goes into 8, so I don't have to go as high as 32. I can multiply everything by 8. So let's try that. Because 4 is a factor of 8, I can do this. So I'm going to multiply this by 8. I'm going to multiply this by 8. I'm going to multiply this by 8. Everything got multiplied by 8, so it didn't change it. It's clear over here. 8y just stays like that. It's also clear over here. The fractions always cancel. That's why we do it. Over here, it's clear that 4 divides into 8 twice. And 2 times 3 twice. And 2 times 3 is 6. The only thing left to do is make sure my x and my y's are all on the same side. So I would do this. I would 8y minus 3x is equal to 6. Now, by the way, some teachers will never let you make a minus x here. And the secret of that is you could just change all the signs. And it will be true. It's essentially multiplying both sides by minus 1. Right? So it all depends on your teacher, but in my opinion, once you have it like this, you have correctly solved it. Notice also, and this is the confusing part, this standard line formula is the same as the fractionary formula you had just figured out. Okay, so this is the same line. Whoops. This is the same line here as that. It's just that this is in slope-intercept format and this is in standard format. This one has essentially just been multiplied by 8. That's the only difference. But since I multiplied left and right side, they are the same formula. So you're going to face that, but at least now we have the formula. Have we answered all of B now? Yes, we have this formula. This red formula, by the way, represents this red line right up there. If I was to punch this into Desmos, it'll go right through this triangle. Read the next square. Draw the right bisector. Draw the right bisector. Okay, here we go. The right bisector is a line that passes through M. Essentially like this. Most people just draw it straight out, but technically it goes all the way through, and it's going to go through the same M point. The trick here is it's 90 degrees to this line. Now you successfully found the slope of this line. So we're going to forget about this red line for now. We're even going to forget about point A. It's not relevant. So in order to find the slope of this blue line now, we need to find the slope of CB, or the black line that's left. Well, as you successfully did it, you should write down the slope formula. M is equal to y2 minus y1 over x2 minus x1. And you should label all your slopes. So I'm going to use 8, 8, and I'm going to use the other point 4 minus 2. And by the way, technically I could use 6, 3 because it's on the slope. But we're going to use 4, minus 2. And then I'm going to label things properly, which means my x2 is equal to 4, which means my y1 is equal to 8, and my y2 is equal to minus 2. So that minus 2 is going to cause me trouble. So it might have been good to use this because there's no negatives. Try to always avoid negatives if you can. But you can take a slope between any 2 points on the line, and 6, 3 is on that line. So now all I have to do is replace it. Okay, my y1 is 8, so it's going to be, since it's positive, it's just minus the 8. And my y2 is minus 2, so I got to be careful here. It's minus 2 minus 8. Okay, good enough. My x2, as long as I kept it in order, my x2 is 4. That's good. And I get 4, and then here's the tricky one. My x1 is, my x1 is not tricky at all. It's 8. Okay, up above I get minus 2, minus 8. You had no problem doing this. You got this right. So you get minus 2 minus 8, it's minus 10. And down below I get 4 minus 8, it's minus 4. And you'd be tempted to say, well, that's it. But fortunately, you also caught this. You said, well, those are both divisible by 2, and those minuses cancel out. And when I divide both those by 2, top and bottom, I get 5 over 2. So you have successfully found not the slope of the blue line, so I shouldn't have colored it blue, but you found the slope between this point, and essentially this point. Which means the right bisector, as you correctly deduced it, is negative and reciprocal. Negative and reciprocal. That means we now have the slope of the blue line, but go back and read the question. Draw the right bisector, then find an equation. So an equation is the line equation, which means we're back to square one, but for the blue line. We're going to use y is equal to mx plus b. Well, fortunately, you found my mx. It's minus 2 over 5. You found my m. X plus b. We also have a lovely midpoint, 6, 3, that we know is also on that line. So we have this. What's our big thing before we try to solve it? What's our big thing? And sometimes it's okay to put the x values in because they will cancel. You won't have to solve it. But I can say my big thing right here is I have a fraction I don't want. What's the number in the denominator? 5. So I'm going to multiply my left side by 5. And I'm going to multiply both my things on the right side by 5. So when I multiply the b, it just becomes that. So essentially, I'm going to multiply everything in here by 5. So all I did was multiply the y by 5, multiply this by 5, multiply this by 5. And you might say, is that left side, right side? Yeah, because when I do it, you put a bracket in. You multiply both sides by 5, but this thing must distribute through. So when I multiply both sides by 5, the beauty of it is this 5 here will always cancel. So I'm left with this, and it's quite clear. That's a much more clear formula. If only I had a xy point to put in there, well, I do. And by the way, it doesn't matter at what stage you cancel the formula. You could go back and do it, put in the y's first. So my y value here is 3, not 6. My x value is 6. And I don't know my b. Well, 2 times minus 6, minus 12. 5 times 3, 15. I've got to get rid of that 12 to the other side, so I add 12 to both sides. You can see it's getting confusing. I get 27 on the left side is equal to 5b. I might have made an error somewhere in here, so I'm going to go back and try another one. When I divide both, I get 27 divided by 5 as my b. And then I want to go back and I want to replace my b in my formula like this. And I got to use the original with the fraction, and actually you could use either because they didn't ask for a specific one, but it would be like that. Notice they both had a 5, and if I wanted to get rid of that, I could just multiply by 5. But let's go back and do that again, but this time with, instead of multiplying through with 5, we're gonna replace our slope. We know our slope is minus 5. Was it minus 5 over 2? No, I think it was minus 2 over 5, right? Yeah, because I multiplied both sides by 5. We know that's our slope. We know we could use a point. Y is equal to minus 2 over 5x plus b. And we could use our points. Well, our points are 6, and our x is 3. like that. So this is another way of doing it in that I don't solve the 5 first, I just multiply it out. Well, it's clear 6 on the left, and it's clear minus 2 times 3 is minus 6. This one might be a little bit easier for you. Now, minus 6 and 5 do not divide, so I have to multiply everything, and it looks like I did a minor error on the other one. I have to multiply both things by 5, everything by 5, so here's by 5, here's by 5, and the b by 5. And the good news is these always cancel out. These always cancel out. What's 5 times 6 on the right side? It's 30 is equal to minus 6. Yeah, I did do an error before. And plus 5b. And so I add 6. Yeah, I have to go check it out twice because I might have used the wrong slope here. And I get that, and when I divide it by 5, I get 36. Now, right there, I know I did a mistake somewhere. So I need to go back and make sure of all my numbers. Very quickly on the slope, I can do 8 minus 3, 5. 8 minus 6, 2. Yeah, indeed, that's my slope. I can put it into the standard formula just like this. Y is equal to minus 2 over 5, just to see where I made my mistake. Plus b, I can multiply everything by 5. This multiplies by 5, this multiplies by 5. And the beautiful thing is this will always cancel out. So then I've got that, so I can replace my values. I probably put in the wrong y's before. Yeah, I did. I put in the wrong values for this. 5 times 3 on this side, minus 2 times 6 on this side, plus 5b. It's clear that's minus 12. It's clear that's 15. So it's the other one I did wrong. When I add it to that, yeah, it's plus 12, so that's correct. And I get 5b. And so on this left side, it's 27 divided by 5. So 27 over 5 is the correct b. And I would be smart to always go and see what happened. You know, why did I get that wrong? And you can stop this at any time, but I just want to see why I got that other one wrong when I substituted in the x right away. So the y over here, I probably put in the 6 over here by mistake. And this is 6. Yeah, I can see already that's what I did. And then plus b. And then this times this is minus 12. And I can see that minus 12 divided by 5 does not work. So I'm going to multiply everything by 5. And over here 5. And I can tell you right now, this is not 5 minus 12. It's 5 times 12. And every time this fraction disappears. There we go. Now it's coming out to 27. This 3 times 5 becomes 15. When I add 12 to both sides, I get 15 plus 12 to the left side, which is 27 is equal to 5b. And that's what happened. I interchanged my... there we go. So then I would go back. Y is equal to minus 2 over 5x plus 27 over 5. If your teacher wanted it in standard form, great. I could have answered it as this. See if you can see what I did there. I multiplied everything by 5. All that happened on the left was the fractions disappeared. And that's the correct line formula as well. Since this question did not ask you for the slope-intercept formula, you can use any equation you want that makes it easier for you. Then use your drawings. That's where graph paper is good. Try to get this. It's the multiplying by fractions that's throwing you.